Alright, welcome back. We're now into section 4. We've talked about ionic compounds and how to name and write. Now we're going to move on to covalent compounds. So if we take a look at our little map here, we can see that all of that stuff in the pink on the left side, we covered that in the last few videos. Now we move on to covalent compounds. So let's talk about what a covalent compound or covalent bonding is. With ionic bonding, we saw ionic bonding was between a metal and a nonmetal. And what held them together was that ionic bond, which resulted from a transfer of electrons. But in covalent bonding, we're looking now at bonding between two nonmetals. In this case, electrons are shared between both atoms. This is how they feel like they have a noble gas configuration. Consider the two fluorines that are being shown. Both fluorines have 7 valence electrons. But if they were to transfer one electron to the other, one fluorine would end up being happy, while the other one wouldn't be. So instead, they have to come close together and actually share electrons in between them. Now, both fluorines feel like they have 8 valence electrons, and therefore feel like they have a stable octet. So now before we get into the naming and writing of covalent compounds, let's talk about their structure, just like we did with ionic. With ionic compounds, we saw that they existed in these large crystal lattice structures. But with a covalent compound, it is possible to actually have just a molecule. Covalent compounds can exist on their own as molecules. And reminder, what is a molecule? It's just a neutral combination of at least 2 atoms in a specific arrangement that's held together by a chemical bond. Specifically, electrons are shared in between atoms to hold them together. These molecules could be simply an element, such as the case of the hydrogen molecule, where 2 hydrogens are bonded together. Or it could be covalently bonded between 2 different elements, such as water, oxygen being bonded to 2 hydrogens. The key thing to note, though, is that covalent compounds can and do exist as individual molecules. Continuing on with that, this is a good reminder of the 7 elements that actually exist in molecule form, specifically diatomic molecules. These elements, which are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, exist in nature in molecular form. If ever you forget which elements are part of the 7, you can always ask Dr. Hofbrinkel. Hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. I know, it's ridiculous, but Dr. Hofbrinkel's pretty smart. Let's talk a little bit more about molecules in terms of covalent bonding. A term to be aware of is called an allotrope. Now, an allotrope kind of sounds like isotope, so don't get them confused. An allotrope is simply an element that comes in very different, distinct forms. For example, carbon. What does solid carbon look like? Well, it actually has a lot of different forms, or should we say allotropes. Carbon can come in the form of diamond, or it could come in the form of graphite. Both are carbon, but the carbon atoms are arranged differently. They are bonded differently. So even though they're both carbon, I wouldn't recommend proposing with a graphite ring and then telling your spouse that, or your fiancé, that it's just carbon. Probably not gonna fly. But nevertheless, that's what an allotrope is. Now, when we start to look at molecules, we're going to start to see that there are different ways to represent molecules. And you'll actually see this more so if you go to organic chemistry. But it's good to introduce the concepts now. Back in topic 2, we learned about a molecular formula. And remember, a molecular formula was the true formula for a compound. But all a molecular formula does for us is it just simply tells us what elements are in the compound and how many there are. That's it, and it doesn't really give us more information than that. So if we consider the molecular formula C2H6O, that's not really being very specific. And actually, there's 2 possibilities for that compound. There's this one, which if you look, has 2 carbons, 6 hydrogens and 1 oxygen, but also it could come in the form of this molecule. This molecule also has 2 carbons, 6 hydrogens, and 1 oxygen. As you can see, these 2 compounds are very different, but they both have the same molecular formula. So the molecular formula oftentimes is not enough for us to have enough information. Instead, what we would need is a structural formula. We would need it to show us structurally how the atoms are bonded. So, if we were to take a look at the examples that are highlighted in purple, we would simply just write out the elements from the simplest way for us right now is just simply from left to right. So if we take a look at the first compound, we first see that we have a carbon bonded to 3 hydrogens. So we would write CH3. The next thing is it's bonded to an oxygen, so we would write an O. And then finally we see another CH3, so we would write that. That tells me a lot more information about the way the molecule looks like. Versus the second one would be written as CH3, then a CH2, and then finally an OH. When we write structures in this way, not only is that giving us more information about how it's structured, but also when you get to organic chemistry, you'll start to see that there are certain, what we call functional groups. There are groups in the compound that actually have certain properties. For example, when I see OH, that tells me it's an alcohol. When I see O, that tells me that it's an ether. So this is going to give us information about how things are structurally put together. So let's take a look at example 7. So in example 7, I have 2 molecules shown. And what I'd like you to do is write the molecular and the structural formulas for each. So remember, the molecular formula just tells us what elements are there and how many of each. It's convention that when you're looking at organic compounds, one in which contains carbon, C is written first, then hydrogen, and then any remaining elements, such as oxygen. So when I write the molecular formula for this first compound, I'm going to write CHO, and let's count how many carbons we have. 1, 2, 3, 4 carbons. We have, let's see, 1, 2, 3, 4, 5, 6, 7, 8 hydrogens, and 2 oxygens. That's the molecular formula. But as you can see, C4H8O2 tells me nothing about how it's structurally bonded. So, right below that, let's write out what this would look structurally. First, we have a CH3, followed by a CH2, followed by another CH2, and then this last part here would be written as C, O, O, and then H. When I look at this structural formula, COOH is actually a carboxylic acid. Once again, when it's written in this structural form, you can easily see those things. Let's look at the second one. The molecular formula here, there are 3 carbons, there are 8 hydrogens, and there's 1 oxygen. Structurally, we would write that as CH3, then CH2, then O, and then CH3. Once again, I can see, oh, it looks like we have an ether. All right, that wraps up the section 4. In the next video for section 5, we're going to start now looking at how to name and write covalent compounds.